Okay, this is exercise 4.7 Year 10 Mathscape. We already looked at question 1 this morning in class, and we looked at question 8 in class. I've also produced a video for question 7, which you'll be sent. Now, for homework, if you could do questions 2, 3, 4, 5, sorry about that, 2, 3, 4, 5, and 6, you can check the answers in the back. Once you've done those. So if just having a quick look at these, we've got a parallelogram. Basically, because you're told that it's a parallelogram, you can assume that two pairs of opposite sides are parallel. That is the only information that you're allowed to use in your proof. Because you can see here in part B, you're asked to show that AB equals DC and that AD equals BC. So you are not to use that in step A, that opposite sides are equal in length. You are not to use that. If it says that ABCD is a parallelogram, you use the definition of a parallelogram, which is two pairs of opposite sides parallel only. You are not allowed to use anything else in this part A. So notice in part B, you're proving that opposite sides of the parallelogram are equal. In part C, you're showing that angle ABC equals angle ADC, so you're showing that opposite angles of a parallelogram are equal. And in part D, they're saying what property of a parallelogram have you proven? Well, in part B, you proved that opposite sides of the parallelogram were equal, and in part C, you showed that opposite angles, or one of the opposite angles of a parallelogram, were equal. In 3, it says ABCD is a parallelogram. Again, you can only assume that AB is parallel to DC and AD is parallel to BC. Okay, you are not to assume that AB equals DC or AD equals BC. You're asked to prove now that the two smaller triangles, so this triangle and this one, are congruent. Then you're going to be showing that certain lengths, that AP equals PC and DP equals PD. Basically, you're showing that they're equal, and you'll have to say what property you've shown. Obviously, you're showing something about the diagonals bisecting in part C. In question 4, they say ABCD is a rhombus. Now remember, the definition of a rhombus is that it is a parallelogram with one pair of adjacent sides equal. So you can assume opposite sides parallel. In other words, it's a parallelogram, and you can assume adjacent sides equal, so that AD equals DC. And you have to just start working through this, okay? So there's just some explanations there. There's no proof, doesn't look like there's a congruency proof in this question, okay? But you have to explain what property of the rhombus you've proven. Same with question 5, there is no congruency proof, but they're saying that ABCD is a rhombus, and they're saying that AC and BD meet at P. They're telling you that this angle is alpha and this one's beta. And they're asking you why angle BCA is also alpha. So look, with this rhombus, you can see the 4 equal markings. So that's the only thing that you can assume. You're not assuming parallel lines or anything here. You're just assuming that AB equals BC equals CD equals AD. So you could be working in this big triangle here. You can see you've got an isosceles triangle. ABC is isosceles, so is triangle ADC, it's isosceles. So that'll be used here. You can also see that this triangle here that I'm outlining, DAB, is also isosceles. So that's going to help you with some of these. Okay. At Y angles, I think you're going to have to use some other properties of a rhombus as well, such as the diagonals bisect the angles at the vertices, to be able to explain why CBD is beta as well. Okay, so you're going to have to do that as well. You have to find alpha and beta, I think, through all of this. Okay, using angle sum of a triangle with triangle ABC. Then you're going to have to explain why AC is at right angles to BD, and show the property of the rhombus that you've proven. my AC is perpendicular to BD, you cannot use that diagonals of a rhombus bisect at right angles, because that's what you're trying to prove. You're going to have to use your information from elsewhere in the question, from parts A, or more than likely just from part B. Okay. And in question 6, you've been told that this is a rectangle. You can assume opposite sides equal in length and that it's got right angles, and you're trying to prove that triangle ABC is congruent to triangle D. Sorry, actually they're overlapping. The triangle ABC is congruent to triangle DCB, so you do have overlapping triangles, but you do have right angles in the corner, and you've got opposite sides equal as well. Okay. And what they're trying to get you to show is that AC equals BD. So as long as you don't use that property, as long as you don't use the fact that AC equals BD in the first part of the proof, you'll be fine. Just the basics of a rectangle, that opposite sides are equal and that it's got 90-degree angles, is what you can use in part A in your proof. Okay. All right. And also you'll find that there are videos for questions 9, 10, 11 and 12 on BC Online as well.